In this video, we are going to learn about the Oersted's experiment. So what is the important point from the Oersted experiment? Actually, Oersted can found that the magnetic fields can be induced by conducting wire. From this experiment, he was able to show a relationship between electricity and magnetism. You can watch the video about the Oersted experiment from the video that I have attached in your My ETS classroom account. After watching the video, you can understand that from this experiment, Oersted was able to show that the electric current within a wire produces a magnetic field. So let's say here I have an electric current inside that wire, inside this wire, and let's say that the direction of the current is going upward like this. So we know that the electric current within a wire produces a magnetic field. So then how can we determine the direction of magnetic field? We can determine the direction by using right-hand rule 2. So in this case, right-hand rule 2 is used to determine the direction of the magnetic field induced by conducting wire. So in the first case here, if I have current going upward, using your right hand, the direction of current is represented by the direction of your thumb. Then your 4 other fingers can show the direction of the magnetic field. By wrapping your 4 other fingers around wire so that your thumb points to the direction of current, you can finally find the direction of the magnetic field. So if we draw the direction of the magnetic field is like the blue line here, so it's like a circular line, making a circular line, and the direction, you can see that the direction is counterclockwise. If we check the direction of the magnetic field in different point, so it will be different. Let's say that the coordinate is like this, so this is x-axis, y-axis, and z-axis. We can determine that the direction of the magnetic field in this point is to the x positive, and in this point is to the x negative. And if I want to find the direction of the magnetic field in this point, the direction is going into the page. And in this point, the direction of the magnetic field is going out of the page. If you still remember my explanation about the notation to describe the direction out of the page and into the page, so I repeat again. In case of the direction coming out of the page, you can use the notation using a dot symbol like this. On the other hand, if you want to represent the direction going into the page, so then the symbol is cross symbol like this. So then if we come back to the first case, if I want to draw the direction of the magnetic field in this point, we know that in this point the direction is going into the page, so the symbol is cross symbol. In this area is cross symbol. On the other hand, in this area, we know that the direction of the magnetic field is out of the page, and out of the page we can draw that the symbol is dot symbol. Yeah. So then by using right hand rule 2, you can easily draw the direction of the magnetic field induced by the conducting wire. The same case can be applied as well to the conducting wire, which is placed horizontally like the second figure. So if the direction of current is to the right, so your thumb is going to the right as well, and you wrap your four fingers along the conducting wire, so you can draw the direction of the magnetic field is circular like this, and the direction is clockwise. So you can draw that in this area by using your right hand rule. You can draw that in this area it's into the page, and in this area it's out of the page. You can easily use your right hand to determine the direction of magnetic field. So if I have the case like this, if I have two wires lying in the plane like in this figure, and the direction is anti-parallel, so the first conducting wire has current directed upward, and the second wire the direction of current is going downward. So then by using your right hand you can determine that the magnetic field in between these two wires is into the page. You can use your right hand to prove this problem. I hope that you can easily determine the direction of the magnetic field after you understand right hand rule 2.